Hello friends and welcome to my video. I hope you have liked my previous videos around the series of COVID-19. And in this video, I'm going to talk about COVID-19 vaccine. I'm going to talk about why COVID-19 vaccine is very important. However, what are the challenges to be faced before a vaccine is being made? In this video, I'm going to talk about what a vaccine is, what are the different phases the vaccine goes through, and why it is a holy grail for COVID-19 vaccine to be made. Before I start, I really like to dedicate this video to the researchers who are working day and night to find a vaccine for COVID-19, and also to the volunteers who have contributed by participating into the different trials for COVID-19. I hope you have liked my previous videos where I have talked about what is COVID-19, and then I have spoken about the importance of mask. But now that we have eased the lockdown, we are seeing the cases are started to rise again. And although the public health measures are very important, to start a normal or near normal life, we need to have a vaccine. If somebody wants to enjoy a football match or somebody wants to go to a cinema hall to enjoy a movie, they should be confident that they go healthy to watch the movie and they return home healthy. And that's only possible when we have a successful and efficacious vaccine. My name is Dr. Pramod Kumar Agrawal, and I'm one of the clinicians working in Ireland. I have a special interest in public engagement and increasing public awareness around current or hot topics. You probably know me from my previous videos where I've spoken about COVID-19, and I've also spoken about some childhood problems. In this video, I'm going to talk about what is a vaccine and how vaccines are formed and what are the challenges for a successful COVID-19 vaccine. So let's talk about what is a vaccine. Vaccine is basically a medication which is given to prevent infection. For example, we know that we have vaccine for polio. When the polio vaccine is given, the person is less susceptible, or person is have less chance to get the infection, or even if they get the infection, they get a less severe form or a milder form of the infection. Similarly, the vaccine for COVID-19 is aimed to make the body an immune system so that the infection is less severe. Scientists are working day and night to develop a vaccine against COVID-19, and so far there are about 180 candidate vaccines being formed. So let's understand what candidate vaccines are. So candidate vaccines are the vaccine which are developed and which are being a full vaccine in the near future. Most of the vaccine has to go through a very rigorous process, and there are certain stages which they have to pass through to be approved to be used in normal practice or for normal population. So let's talk about what are the different materials scientists are working with to make a vaccine against COVID-19. I'm pretty sure you have seen a picture of COVID-19 virus or SARS-CoV-2 virus, which has spikes proteins on its surface and some genetic material inside. So what scientists are using it, they can use either the virus itself in a less lethal form, which is called attenuated form, or they can use the surface proteins. Number two is the surface protein. They can also use the genetic material of the virus, which could be an RNA, or they can use DNA, which is a novel method to use the virus. Or they can use what we call repurpose vaccines. For example, the BCG vaccines or the polio vaccines. They are already used for polio or tuberculosis respectively, but those vaccines can be repurposed to fight against COVID-19. So let's see again. So it could be the whole virus in a less lethal form, or it could be the proteins on the surface of the virus, or it could be their genetic material, the RNA or DNA, or it could be a repurposed vaccine. So there are the different types of vaccine. Now let's talk about what happens if a vaccine is given. So when a vaccine is given, body tries to fight against that vaccine, and because it's a small amount, or it's a non-lethal form, or it's a form which is not dangerous to human body will make what we call antibodies, which are the protective, as you can say, they are the protective ammunition of the body, and then they will clear those vaccine particles from the body. But body is very smart. It not only clears the vaccine particle itself, but it also remembers that next time something like this come, it will be able to make the antibodies very quickly. And that is the main purpose of the vaccine, that if the antibodies are made against the vaccine and the person get infected with SARS-CoV-2 virus, the person SARS-CoV-2 is cleared quickly and the person doesn't get sick enough. So that's what the different type of vaccines are. You might ask yourself, what is the current state of vaccine formation? At the moment, as I said, there are about 180 candidate vaccines in the market. However, only 20 are being approved or being used for clinical phases. So a vaccine has to go through different phases of development. So once the scientist has identified which part of the virus or what type of vaccine they are going to make, they will do the testing in the laboratory setting, which is called preclinical setting. And once they are happy with the preclinical setting, they go into a clinical phase or clinical trial, and which is again subdivided into 4 different phases. Unfortunately, most of the candidate vaccine will be limited to preclinical stage. They would not make to the clinical stage. But thankfully, there are about 20 candidate vaccines which have made to clinical stage. And again, it's very important to understand that we need vaccines which act differently, which have a different mode of action, so that we can have enough vaccines to cover the whole population. So they are not fighting against each other. They are made to help to cover. If we have a successful vaccine, we probably need more than one type of vaccine. Once they start the clinical phase, they start with what we call phase 1, which is basically try to ascertain that vaccines are safe. So they are usually typically done in about 80 patients. They are healthy volunteers. And once it is known that the vaccines are safe, they are moved to phase 2. And phase 2 is when they check the safety of the vaccine, and they also check efficacy, if there is enough antibodies made in the human or not. And they are typically done in about 300 patients. And once the phase 1 and phase 2 are done, the vaccines move into phase 3, and which is typically done into about 1,000 patients. And at that stage, the vaccine is tested for its safety, its efficacy, and is also tested in different subgroups, for example, in children, in pregnant women, in older patients, and etc. Once the vaccine has gone through preclinical phase, the phase 1 of the clinical, phase 2 and phase 3, it's submitted for approval. So different government agencies give the approval depending on the safety and efficacy of the vaccine. And then the vaccine enters into phase 4, and where the vaccine can be given to the mass population and the long-term follow-up is done. As far as I know, there are only one vaccine which has been approved, and that is being trialed in China, and especially in the military population, which has entered the phase 4. But there are 2 vaccines which are very promising at the moment, and there is some good news. So the Oxford vaccine, which is called CHAdOx1, it stands for chimpanzee adenovirus Oxford 1, which is being trialed simultaneously in phase 2 and phase 3. And the trial is run in UK, in South Africa, and in Brazil. And there is another vaccine which is very promising, is the Imperial College vaccine. And again, this vaccine has a novel mechanism of which uses a self-amplifying RNA. And the difference between those two vaccines is that the Oxford vaccine, you need 1 dose, and the Imperial College vaccine, you might need 2 doses. However, as I said, they might have to combine those two vaccines to get an effect. Now that we know what vaccines are, how vaccines are formed, and what are the different stages a vaccine has to go through, let's talk about why it is so difficult to have a vaccine. To be honest with you, usually it takes about 10 years to have a vaccine approved for clinical use, because the safety is the biggest issue. A vaccine has to be safe before it is being given to a large population, because we don't want to do any harm giving a vaccine. Not only that, there are other problems. For example, if we develop a vaccine, we have to make sure that it works. Okay, even if it works and we have a vaccine, what about the production? Would you have enough produced at the time to cover the whole global population? Even if we have enough produced, do you know how we are going to give the vaccine? Are we going to give it in an injection form? Are we going to give in a tablet form? Are we going to give it in a patch form? Or are we going to give it in the infusion in a hospital? So those has to be optimized. And let's say we have optimized all those. Will the virus change itself by the time we have developed a vaccine? Because genetic drift, what we call the mutation in the virus, can happen. And that's why we have this novel virus. And if we have a vaccine, and by the time we have a vaccine, if the virus has mutated, virus has changed its genetic component, this vaccine will not work as we have trialed for. So that's another component we have to be very cautious of. And further to that, if we do not have enough vaccine to cover the whole population, the ethical question, the ethical dilemma arises. Who will be the one, or which population will be the one to get the vaccine first? Will it be the healthcare professions? Will it be the frontline workers? For example, the ambulance people or the policeman? Will it be the pregnant woman? Would it be the children? Or would it be the extreme ages? So that has to be also weighted depending on the vaccine development process. So taken together, it is not an easy process to have a vaccine. However, we need a vaccine so that we can go back to normal life. And that's why I want to thank the researchers who are working day and night in look out for a vaccine, and also the volunteers who have participated and who are going to participate to have a successful vaccine in the near future. But in the meantime, it's very important that we continue to follow the public health measures. We continue to follow the local guidelines regarding hand hygiene, regarding cough etiquettes, regarding social distancing. And also, please do not forget to wear a mask when indoors, because now we know that the coronavirus is an airborne transmission. So I hope you have understood this video where I've spoken about what vaccine is, how the vaccines are made, and what are the different stages it has to go to make a vaccine. I hope you like this video, and if you have liked this video, please do not forget to hit the like button or leave a comment below. And to continue to know about my future videos, please do not forget to subscribe. I hope to see you in the next video. Until then, stay safe.